Hi, everyone. First of all, bear with me. If I start losing my voice in the middle of the talk, it's not on purpose because I was sick the whole week and I was really saving my voice to be able to speak today. So I hope it all works out. First of all, who I am? My name is Prudnikova. I'm currently a head of international cybersecurity services at Secure, which is a Bureau Veritas company. Remember Bureau Veritas because we are going to talk about it later, why it's important and why am I also so interested in maritime cybersecurity. I've been in the field of cybersecurity for the past 13 years, I would say. I have 2 master degrees in cybersecurity and I have a good understanding of IT and OT. But recently I've been mostly working with OT environments. If you were here last year, you probably heard me speaking about the automotive cybersecurity. And this year we are going to talk about ships. But first of all, let's support the Halloween topic, and I would like to read you a bit of a horror story. So imagine, on a dark and stormy November night in 2002, off the coast of Spain, a rusted old tanker named the Prestige, it's here in the picture, struggled against the raging waves. The ship was loaded with a dangerous cargo, over 77,000 tons of thick black fuel oil. It was a haunted ship of sorts. 26-year-old, patched and creaking, yet somehow classified as seaworthy. But that night, nature had other plans. As the storm intensified, a deep, ominous crack appeared in the ship's hull. The crew felt the shift. They heard this eerie groan of metal giving away, and they knew something was horribly wrong. They scrambled to radio for help, but their calls were met with silence. No port wanted them near. Their cargo was too risky, too dangerous, so the Prestige was left drifting, helpless and unwelcome, with a crack that widened by the minute as the ship itself was splitting in fear. You see, months before, inspectors had looked the ship over and given it a clean bill of health, but their judgment was flawed. Because, in truth, the Prestige was a ghost ship, one that should have never been at sea. Now, on the mercy of the storm, the ship's face was sealed by this really scary oversight. Finally, with a bone-chilling crunch, the Prestige tore in half. Dark oil spilled out like a flood of nightmares, spreading across the ocean. It slithered over the waves, blackening the water in a suffocating blackness, killing fish, birds, and sealing the beaches in sticky sludge of miles. The once bright shore turned black. For months, locals saw the effects everywhere, a thick, haunting residue that refused to wash away. The story of the Prestige is a reminder that even the smallest mistake, like misclassifying an aging ship, can have the dire consequences and unleash disasters that haunt our world. Well, the story is real. Of course, I made it a bit more dramatic than that. But we are going to talk about why it's really important to talk about regulations. I know we all don't like them. Why it's really important to classify things correctly. And we are going to talk about the history of classification of the ships. The agenda for today, we are going to start a bit about cybersecurity and maritime and why it's important. We are going to look at the first cybersecurity regulation. Then we are going to look at the upcoming, actually new regulations in cybersecurity. Then we are going to look a bit at the best practice. And as always, I like to wrap up things with study case. And we are going to look at the study case of a threat modeling for the cruise ship. Right. So let's start with evolution of maritime cybersecurity. First of all, maritime is one of the oldest industries known to man. It's been there for many years, and it's actually really vast because it includes shipbuildings, maritime shipping, ports, offshore wind, and many other industries. And since ships deliver actually 80% of world trade, you can imagine that if there is a disruption in any of the sea routes or any of the ships, well, that will have actually major economical consequences. I'm not even talking about health, environmental issues. And the thing is that the new technologies such as industrial control system and OT environments are now more complicated because now they're connected, because they have satellite communication. And this is new. And that's why the topic is not really known, but we are going to discuss a bit what's the difference, let's say, between the maritime and overall industrial cybersecurity. So first of all, there are new threats specifically related to maritime. First of all, because if we're talking about maritime, well, we're talking about pirates, actually. However, when we're talking about pirates, we're not only talking about the pirates that are physically trying to take over the ships, we're talking about the pirates that also use the digital means. And the thing is that most of the ships are now connected to the shore as well. Meaning, if you can hack into infrastructure of the port, you can hack into the ship. Of course, also navigation system can be compromised. We are going to talk about it in a study case as well. Of course, harming reputation. I think one of the known incidents was not an attack, but actually more like a mistake in the ship functioning. But still, it was in the Canal de Suez. Probably many of you heard about it. So they claimed over $300 million of the loss just because of the reputation. Of course, because of that, maritime industry is also slow to actually embrace the digitalization because they're afraid of cybersecurity attacks. Moreover, now most of the biggest companies involved in maritime have been victims to the attacks. And again, we are going to talk about it. So far, there was nothing major in terms of the impact, but we see that the attacks are starting to arise. And we need to be ahead of the attackers. And of course, we need to be aware of the legal issues. As I mentioned, there are some regulations right now. We're going to talk about the flag inspection and what is the flag inspection, what is port control inspection. But of course, we also need to be thinking about that companies can be sued if there is data leakage and so on. And moreover, why it's important to talk about maritime cybersecurity, because the impacts are also huge. So if there are attacks on any type of equipment, and again, we are talking about standard equipment that you can imagine on the factory. People who work in industrial cybersecurity can imagine the PLC and so on. So imagine if one of this equipment is compromised. Well, all the vessels normally have the same equipment. So you compromise the whole fleet. The same, if there is an attack on a ship owner, you will actually compromise the whole fleet, because in most cases, they're all managed centrally. And moreover, I think this is one of the most scariest. Luckily, no attacks happened yet. But imagine if there is a fully autonomous ship and somebody can hack into that. Then, of course, the business disruption and time to restore. Because we are not only talking about health, safety, environmental issues, but we're also talking about business issues. Because all of those ships, they have email on board, right? If you can just disrupt the IT network there, you can cause huge potential loss for the companies in terms of the business. And also the cost of downtime is actually 50 times more than normally requested as a ransom. And the last part is also something that's been happening already, is a cargo loss. Because most of the containers, they have tracking. And if you can hack into that tracking, or if it's just malfunctioning, you can lose your whole cargo. And again, this has been happening already for a while. So far, not because of the cybersecurity attacks, but you can imagine that still the impact of this kind of potential attack will be huge. Right, so 3 of the most known accidents that happened in the maritime cybersecurity on the slides. So I think one of the most I'm not going to name the company because it's a competition, I'm going to be nice. But this company has the management system that is basically installed on more than 1,000 vessels around the globe. And, well, it's been hacked. The details are not really disclosed, so I don't know much about that. But the thing was that they had to shut down the whole server. So all the software that was installed on the vessels was still working. Luckily, they shut down the servers on time. But the thing is that software is actually responsible for things like maintenance of the ship, crew operations. But another really important part, that it's also responsible for the monitoring on the environmental conditions. So, for example, how much pollutants does the ship actually give to the environment? So if at that point there is a faulty data, it can actually hinder this monitoring of the pollutions. And in this case, we are actually having the negative environmental effect. Because if you don't understand that you have too much pollution coming from your ship, you cannot prevent it, because there's specific mechanisms that the ship can do. For example, so-called slow steaming, when they start to go slower to decrease that. But if you can hack into that, and if you can mess up with this data, this is a huge environmental issue. Two other incidents didn't have that big of an impact. So one of them is the Port of Lisbon, which happened in 2022. Again, it was a ransomware claimed by Logbit, but luckily they only managed to log the website and some internal system of the Port of Lisbon, and actually there were no major impact for the operation of the port. But still, again, this is already happening. And another one is Singapore shipbuilder, when an unauthorized user gained access to the IT networks through the third-party software. So again, here we are talking about supply chain. So again, we see that actually all different actors in the maritime chain have been already affected. Right, so now that I scared you a bit, let's actually discuss what is being done right now to address those new threats. And we will start, of course, with talking about regulations. I know that, let's say, compliance is not the magical pill, right? But unfortunately, with this kind of industries like maritime, they will not take cybersecurity seriously unless they're forced to. And we've been seeing that in many other industries like automotive. It started all with regulations, but now if you look at the automotive industry now, let's say 5 years since the first regulation was issued, well, now it's actually best practice by design. Cybersecurity is there. We are hoping that maritime will move in the same direction. So, in order to address those concerns and cybersecurity risks, International Maritime Organization actually issued the resolution called 428, which is talking about cybersecurity for ships in service. Basically what they say that all the ships should introduce cybersecurity into their safety management system. They need to think about cybersecurity risks and how to address it. This resolution was issued in 2017 and became mandatory from January 2021. However, in practice, I saw what many companies did. Well, they basically wrote a policy where they say, yeah, I take cybersecurity into consideration, and that's it. And the thing is why it happens, because who is checking that? Well, the flag inspections. Who are the people who are doing flag inspections? Where the people are not cybersecurity experts. So for them, they cannot grasp, okay, what does it mean to address cybersecurity? So that's why so far, this regulation was not really effective, because it was really a compliance check and nothing really happened. So in order to address that issue, the ICS, we're going to discuss what it is later, issued 2 other regulations which are way more detailed and actually talk about classification of the ships and classification of the equipment that is installed on the ship. So in this case, it's not going to be the flag inspection who is going to check whether cybersecurity is implemented, but actually classification society. Well, for example, like BV. So people who actually know what cybersecurity is. So they're not going to just make it as a okay check. They're actually going to make sure that cybersecurity is included in the design. Those requirements have been postponed for quite a while. They finally have been approved from 1st of July 2024, meaning this year. But it's only for the new ships. So if you start building your ship from 1st of July 2024, you already need to take cybersecurity into your design of your ship. Right. So a bit of the details about the first regulation. As I mentioned, it's quite high level, because it basically just says that approved safety management system should take into account cyber risk management. Okay, quite vague. So they're talking about asset inventory, they're talking about risk assessment. They say that the ship owner should have a cybersecurity policies and some procedures, right? But it's all the documentation. They don't ask how it's implemented. And of course, as we said, who is actually checking that? Well, in this case, it's flag state inspectors who are checking that. Oftentimes also port state controls. But again, as I mentioned, so who are the flag state inspections? So every ship that is, well, basically wants to go to the sea, they need to be registered in the country where they actually were built. In this case, they will have a flag of this country. So that's why it's called a flag state inspection. So in this case, the country that issued the certification for the ship will be responsible to check that this ship actually meets all the requirements of IMO, of International Maritime Organization. Port state control is actually a control that is in every country where there is a port. And they can check all the ships, not only the ships that are flying their flag, but actually any other ship that goes to their port. And again, they can check all the type of regulations, including, of course, the IMO regulation for cybersecurity. Back to the topic, they don't have cybersecurity knowledge. So for them, it's really a checklist. Okay, do you have a cybersecurity policy? Yes. Do you have risk assessment? Yes. Done. Right. So, as I said, this thing needs to change. So that's why the International Association of Classification Societies, this is the independent organization where all the classification societies for ships, companies like BV, DNV, Lloyd Register, are part of. They decided to create 2 other regulations specifically for cybersecurity. So one is UR E26, which is talking about cybersecurity design of the vessel itself, and UR E27, which is talking about security of the equipment which is installed on that ship. So let's talk about this history of why actually this classification is important, because it's also linked to the story that I started this talk with. So back in the day, all the merchants, they faced the issues that there are storms and pirates and unstable ships. So they had to have the bottom loans, basically those loans only repaid in the case when the ship actually returns. So if they lose the cargo, they don't have to return this loan. Well, if you think about it, who will give this kind of a loan because it's a high risk? Well, the thing is, with this high risk, also, of course, came a high interest. So that's why a lot of companies who were giving this kind of loans, well, they were interested. By the 17th century, actually, London was one of the major hubs for maritime business, and the London coffee houses actually became the hubs of this kind of maritime deals, where all the merchants, insurance companies, and other writers were there together discussing, okay, is that ship a risky ship? Is that ship a risky ship? And so on. And this actually led for the creation of the first classification society in 1760, which was called Lloyd Registry, that was discussing, okay, how to classify a ship from A to D, basically on how risky those ships are. Well, why is it important? Because it was the first step to start, let's say, coordinating these kind of activities on a world level. Well, again, BV was actually, Bureau Veritas, was the second classification society that joined in also classification of the ships. It was one of the first businesses that actually BV started. And this expanded the whole classification society beyond just London to the whole Europe. And overall, over time, all these classification societies, they have set the rules that are applicable for all the ship construction, inspection, and management. And basically, because of this contribution, now we have more safe travel in the sea. But of course, the thing stays, and I don't know how it's going to be resolved or whether it's going to be resolved, that the rules of each classification society are different. Even if we're talking about the same regulation, the way they implement and check that will slightly differ. So a bit more about the regulation. So as I mentioned, the UR E26 is talking about resilience of the ship itself. Basically, it's talking about in which way IT and OT should work together on the ship. Again, imagine it as a factory, and it talks about 5 topics like equipment identification, protection, attack detection, response, and recovery. Nothing new, they just took it and implemented it in maritime industry. And another one, UR E27, is talking about cyber resilience of equipment. So we're talking about supply chain, right? So whoever wants to sell equipment to be installed on the ship, they need to show so-called type approval certificate where they prove that cybersecurity is actually implemented. So what will it actually change? Well, first of all, before, cybersecurity in the design of the ship was not mandatory, right? So everybody could do it, not do it, but from 1st of July, for a new ship, it is mandatory to have cybersecurity taken into consideration from the very beginning of the design phase. And it means that the expertise of cybersecurity are actually missing because it was never done before. So that means whoever is an architect of the ship needs to learn new technologies, in this case cybersecurity technologies, to implement that into the design phase. That means that we are lacking the expertise. So a lot of those companies, they will probably need to hire external support. And another thing we saw before, that monitoring should be there. So right now there are a lot of mandatory monitoring coming from the ship. Well, now it should also include cybersecurity monitoring. Right, so now let's take a look, okay, how do we actually do that? Let's say, imagine you are a ship owner. How can you start? And let's even start thinking, okay, is the ship a suitable target? Will the attacker want to attack the ship? Well, let's start from the point that, well, the design life of a ship is at least 25 years. If you look at the IT device, it will be 3 years. The ship age is around 10, 15 years. Again, if some of you knows industrial cybersecurity, it's a similar approach. But the thing is, because we're talking about 10, 15, 20 years, well, the equipment is really old. So the average ship will operate Windows NT, support for which has ceased in 2014. But the bad part is it's also connected to the ship OT, operational technology, and actually what the operational technology does for the ship. It controls engines, steering, and ballast operations. So if you can hack into the IT part, which a lot of people can do, you don't need to hack into OT because it's directly connected. And then you can take control of the engine of the ship and the steering of the ship. So that's why it's really important from the very beginning in the design to implement cybersecurity. And basically, when you think about a ship, think about a floating factory. Because again, as I mentioned, it's the same equipment. Right, so again, what a ship owner can do already now, they need to at least start thinking about risk management process. I imagine they have a ship. Of course, it's too late to change the design. You can still consider firewalls and so on. So standard things, again, when you need to separate IT and OT environment. Then they need to start looking into cybersecurity management system. So the full system, okay, even though my design might be not secure, what can I do on top of that based on the risk that I have to actually address those risks? And of course, follow up with testing. And the last part is, of course, focus on the suppliers, because we also discussed that one of the known attacks was actually coming from the equipment suppliers. And as always, people are the weakest thing. So educate and train the ship crews, because social engineering on the ship is a big threat as well. So how can you start doing that? Well, first of all, again, standard approach. You can do the gap assessment if you have any policies to see where you are. Because it's a regulation, it doesn't necessarily say which type of a framework you can use. You can look at IEC 62443, my favorite standard, NIST CSF, and so on. Then you build your processes, and then you implement those processes. Again, this is not specific to maritime. This is a normal practice of how you need to address to cybersecurity. And a bit about the specifics of the pen testing of the ship. So, again, this is quite a new field. So, what we've been doing at Secura, actually, two types of scenarios that we look into. First of all, the offensive security on the onshore infrastructure. So basically to see whether you can hack the ship from the onshore, because the ships do depend a lot on the onshore connectivity as well, especially when they're at port. So in this case, you just think about the standard IPT test, but of course with some specific protocols for maritime. And another one is just the pen test of the OT infrastructure of the ship, especially with the focus on the separation between IT and OT. Again, this is more or less the standard OT pen test. However, it's really important to keep in mind that comparing to the factory, which is always at the same place, ship is moving. So meaning that we have a moving threat landscape. So when the ship is at sea, most likely it doesn't have much connectivity. Maybe a couple of communication points through satellite connection. But the moment the ship actually stops at port, they need to start maintenance, updates, and so on. That they need to connect to internet. So again, when you're doing this kind of testing, you need to consider both scenarios. If the attacker is on the ship when the ship is at port, and when the attacker is on the ship when the ship is at sea. And we are going to look at, during the study case, what can be the potential threats. Right. Now, study case. I really like threat modeling people who know me, it's not a secret, because I like to see how things work. And I think threat modeling gives you the better understanding how things work before you can understand how to hack into that. So one of the first exercises that we did for the maritime industry was a threat modeling of the cruise ship. Big name. You probably saw that ship because I saw it a couple of times in the port of Rotterdam. Unfortunately, it happened during Corona, so we didn't manage to actually go on site. So we had to rely a lot on the network diagrams, on some pictures, on some videos. One of our consultants actually managed to go there for like half a day, but that's why maybe the results were not complete, but it gave a good understanding how the ship actually functions. We had two networks in scope. One is IAS network. So what is IAS? It's an integrated automation system. And actually it's responsible for cargo control, alarm and monitoring, ballast handling, information management, and also HVAC. This is important because we are going to talk about HVAC as one of the threats. And what is a breach network? Well, breach is basically where the captain is, right? So breach is our main control center of the ship. And it has all the navigation systems in there. Again, it's normally a closed room, but this is something to also keep in mind. And well, as I mentioned, we had some input for that. We also luckily had access to interview cybersecurity experts and engineers of the ship, and we used the adapted version of Stride. Right, so I will only show a few examples of the threats, way more. But one of the things that we identify, that HVAC system was actually connected to wireless network, and basically because some of the sensors needed to be connected to the Wi-Fi on the ship. And in this case, the whole wireless network of the ship, because it's a cruise ship, so people need to have Wi-Fi. So it was the same Wi-Fi that people used on the ship. And it used the WPA2 with a pre-shared key as a security type. Well, let's say secure enough. However, if you still think about it, if you have an attacker who is already on the ship, he doesn't need to know much about the HVAC, but can still conduct a brute force on our pre-shared key, and in this case, gain access to HVAC and just control the HVAC. Why is it bad? Because, of course, HVAC is responsible for your temperature control, for your air quality control. Imagine you are at sea in the Caribbean where it's 40 degrees outside and you don't have air conditioner. Well, that's a really big risk for the health of people. Then, of course, if you're already at the HVAC network, you can also start getting an understanding of other connected systems and other things. You can actually try to shut down the HVAC using some known vulnerabilities and so on. Of course, we gave some recommendations as well, because that's also the purpose of threat modeling. Okay, at least use some strong password, because they used the default password, which was like 6 characters or something. Or better, of course, implement the certificate-based authentication. And of course, if it's possible, do not breach it to the Wi-Fi public network. At least have a separate Wi-Fi network for these kind of things, which are really important. Another big threat that we identified is the fact that the whole IAS network, and we remember there were different systems like cargo control and so on. It was just a single flat network, no firewall, nothing. Of course, the main network equipment wanted a separate room, but there were network ports in the holes. So basically, when you walk around, you can just connect to any network port, and you're in the network. That easy. And when we performed some network scanning, because as I mentioned, one of their experts actually managed to go there and do this, we saw that they also use a telnet port for administration. Right. Again, the attacks are quite straightforward, right? You go there, you connect your laptop, and you are in the network. I'm not even going to explain that. Since you're already on IIS network, you can do whatever you want. There is nothing. You are just basically there. Of course, standard remediations included, okay, disable telnet, but also disable all the physical network ports which are accessible outside of the secure room. Also have the proper segregation of the network. Do not have one flat IIS network, and also encrypt your traffic, because that was also not done. And the last one is specific to maritime. That was also an interesting one for me. So, how the navigation is done. each ship has this so-called ECDIS, Electronic Chart Display Information System, which is basically used for the navigation. And it's actually is compliant with all the IMO regulation. However, of course, since it's a map, it needs updates. Well, because when you're at sea, there is no internet normally, so how do you update it? Well, apparently there is somebody coming with a USB stick when you're at port, with a random USB stick, they plug it into the bridge, and they update it. Again, the threats are quite straightforward. So, first of all, you can first corrupt the cloud, and then, of course, you have your malware on your stick that you insert into your navigation system. Then, of course, you might not even know that your USB stick has any malware on it. In this case, if you can mess up with the navigation system and with the maps, well, we can have a Titanic in this case, because normally they don't rely, like, it's not like a captain is there looking, okay, do I see my iceberg? No, they actually rely right now on the systems. So if it's not there, they will not see it. And again, the remediation quite straightforward. Well, first of all, have some operational procedures in place. Do not put just a USB stick into your directly SDSC. Run it through the malware, anti-malware software at least, right? Or better not use the USB sticks at all, or at least have the restricted USB sticks that are only used for that specific purposes. They may be somewhere in the safe. Yeah, again, nothing crazy. At least some best practice would be good enough. So what were the next steps that we did? I'm not going to talk about it because I didn't do it myself, but we basically proposed 2 pen testing scenarios. One was called Be My Guest, basically, as I said, trying to be a hacker on board to perform attacks. Again, with different scenarios, whether we at sea or at port. It was also kind of funny to try and catch the ship because it was constantly moving and we needed to be there. And another one was called Out of Sight but Not Out of Mind, basically trying to hack from the onshore to the ship itself. Right. Well, that was it. So just some key takeaways. First of all, it's really important to understand that maritime is a critical sector, right? We discussed that 80% of the shipping for the world trade is done by the sea. And the attacks are already there, and we need to stay ahead of them. And the impact can be huge, because it's about safety of people, it's about the health of people, but it's also about environmental concerns. These prestige stories that I told you, it's actually one of the most environmental effects that happened in the past 20 years. Another part, that ship is basically a floating factory. It's the same vulnerabilities that you will see generally in IT and OT environments. But on top of that, you also have a complexity of the shifting threat landscape. So when the ship is at sea, it's one threat landscape. When it's at port, it's another one. And it's important to keep that in mind when you build your cybersecurity around that. And the last one, well, maritime cybersecurity is new. We actually don't know much about that. When we started working with that 4 years ago, I didn't know much about the maritime, how the ship works, why. So when I understood, okay, it's actually a factory, but not just a factory, we need to have experts, because also regulations are there, but attackers are also there. Right? So we need to educate more people to understand that maritime is important and that we need to protect this sector. And that's it. Any questions?